Hello, everyone. My name is Jim Ryan, and I lead Altair's Global Academic Program. I'm very pleased to be here with you today to help you better understand how Altair helps its academic customers like you. What I'm come prepared to talk with you about today is really for all our users in academia, whether those are students and or faculty. I'd like you to have the big picture overview of our Global Academic Program, specifically what you can accomplish with our Altair software products, which products are available to you from Altair, how you can access them, meaning download and install the executables, and then how you can get started using those products for your coursework, projects, thesis, and more. And last but not least, how you can obtain help when and if you need it. Now, how you use our software products is going to be detailed number 1 and number 4 in additional sessions. But I'm going to focus more on the big picture here. I'd like you to better understand, come away from this session knowing more about Altair. Our vision, as stated by our CEO and founder, Jim Scapa, is to help our customers leverage computational science to drive intelligent decisions in order to make a more connected, safe, and sustainable future. Now, that's all our customers. Our academic program's mission is to support that corporate vision by enabling our academic stakeholders like you to leverage our same computational science solutions, again, to drive intelligent decisions, especially to help students be what we call real world ready to innovate, ready to leverage technology to make the world a better place by designing better products faster. Our academic program strives to achieve this vision in 3 main ways, what we call our 3 pillars. One is to help faculty course instructors who are teaching first principles and theory to complement those concepts with software that can bring those concepts to life, make them more dynamic, more interactive, more understandable, so that the students kind of get why they're learning this technology and how it's going to apply to their jobs in the future. The second pillar, shown in the middle here, we strive to help students directly apply our technology on projects. In the case of project-based learning, we really are strong supporters of PBL, but also student contests and competitions. And I'll show you a couple examples of those in a moment. The third, on the right pillar, is our desire, our goal to foster stronger 3-way bonds between our academic customers, shown on the left of the circle, the industrial customer companies we work with, and around their common interest in jobs that involve use of Altair technology. So students want to compete and win the premier jobs, the best, most stimulating work, and companies are striving to find young talent that can help hit the ground running and applying that technology at their companies. So that's really what we mean by 3-way bond. All right, so what can you accomplish with Altair software products? Well, this slide is meant to give you a big picture overview. It's not complete or exhaustive, comprehensive, but hopefully you can kind of get what we're trying to convey here. This is some of the many student competitions, I should say, that are supported by Altair. We'd like every team in these competitions to be able to benefit from our technology, whether it's building ground vehicles or aircraft, robots, rovers, rockets, you name it. Anything that is sort of a device, electromechanical machinery, those sorts of things can be designed, built, and tested on the computer using Altair's technology in order to make sure they work as intended when physically built and operated. I'd like to share with you now a couple stories to give you some examples of what you could do if you're not already doing these sorts of things with your work and your perhaps teamwork if you're on a team. This story comes from the University of Michigan, where their solar car team participated in the World Solar Challenge in Australia a few years ago, where they were needing to drive approximately 3,000 kilometers their solar-powered vehicle while minimizing the travel time. That was the challenge objective, the whole solar challenge. The solution for them was to make sure that their vehicle worked as well as possible and achieved their own specifications and objectives for the vehicle performance. They did that by leveraging Altair Inspire software and OptiStruct software for optimizing the metal and composite parts, They making improvements to the aerodynamics and lightweighting parts so that increasing the energy efficiency and making the range as long as it could be, as fast as it could be, while satisfying the strength and durability requirements. It's an optimization game, right? If we lightweight things too much, they might break. So we have to find the optimal balance point. They also used our multi-body motion products for simulating their vehicle dynamics and making sure their suspension and driving maneuvers would work as intended. The value to them is they came away with better designs. In particular, one they shared with us was a very innovative mono-fairing design. They were able to readily change vehicle parameters in their computer models to say what will happen, do what-if studies, as we call them. What if we change this? What if we change that? Is that going to improve the vehicle performance or make it worse? And last but not least, they were very pleased that Altair engineers helped them when they needed it. That's what we pride ourselves on doing, is supporting our customers in their time of need. So summing up very well, I think Clayton Daly, the team captain, said to simply participate in competitions like this World Solar Challenge, teams don't need to use leading tools like Altair's technology, but in order to win, you do. So that's what we're trying to help you do, is get a competitive edge, beat your competitors in the competitions you participate in. Another proud story that we like to share comes from Europe. A team out of ETH Zurich School and the Lucerne University, the AMZ racing team. They wanted to break the world record for acceleration of electric vehicles with their Formula SAE car called Mython that you can see on the right here. They leveraged Altair's flux and flux motor technology for motor design to simulate how their motors would work on each of the four wheels. By doing that and optimizing the performance of those motors, they were able to obtain impressive power output, 240 kilowatts, which enabled them to indeed break the record, getting from 0 to 100 kilometers per hour in under a second, beating the previous world record by a whopping 30%. Now, the leader of their motor team, Jan Bernard, said it well again when he said, boy, working on this car and trying to break this record was intense, in addition to all he had to do for his coursework and study degree program work. But it sure was fun for him to simulate and design new vehicle concepts with their motors in order to achieve their goal. The third of my three stories here comes from a robotics team in the United States. This is actually a pre-university team. These students are aged 14 to 18 before they get to university. And they compete in what's known as the First Robotics Competition, or FRC, annually. This team wanted to be able to design, build, and move their robot around a playing field in order to pick up and place certain game pieces in order to score points. But while bouncing around the field, moving very quickly, maybe even hitting some walls or barriers or other robots, they're not supposed to, but that sometimes does happen, they broke one of their components on their robot, as you can see here. Their solution was to, again, leverage Altair's topology optimization, structural analysis technology. In this case, it was Altair Inspire. They simulated this piece with the loadings that they expected would happen during the driving of this robot on the field. They showed that, yes, indeed, they could predict exactly where it broke. Then they redesigned that part in ways that would have been hard to do just through human intuition, using sort of AI, if you would, artificial intelligence built into our topology optimization software. Then 3D printed that part, put it on the robot, and never had any breakage again afterwards, despite competing in dozens of competitions since then. So their part was 6 times stronger than the previous one. They were able to rapidly and affordably 3D print it because they have cost limits for this robot competition. They also have time limits, so they need to be able to quickly swap in and out parts. Their work here earned them a prestigious Engineering Inspiration Award. They were very proud of that. And as expressed by one of the team members, 17-year-old Colin Dagg, he said, by optimizing the topology of that part, they really were able to achieve their goal of making it stronger and only slightly heavier. So that's the big picture of what you guys can do with Altair technology. Now let's see how different products can help you achieve your goals. We have over 100 products in our broad portfolio of technology from Altair. They're best expressed in 3 categories, as shown here on the bottom, what we call our different platforms. The Altair HyperWorks platform is our oldest and strongest, most mature It is aimed at design and simulation of the types that I just showed you in those stories. You're going to be able to access virtually all the products in that suite or platform of tools. More recent acquisition and organic development has taken place at Altair in the area of data analytics, artificial intelligence, and machine learning, what we call our Altair Rapid Miner platform. And you're going to be able to take advantage of virtually all the products in that portfolio as well. The middle platform is more aimed at industrial applications, high performance computing of the type that people in companies need more so than people in academia. Though if that's of interest to you, we could talk about making that available to you as well. But the HyperWorks and Rapid Miner platforms are what you're going to focus on the most, I think. And those are going to enable you to do modeling and simulation in the areas listed here. Again, quite a wide range of domains and disciplines that you can look at, ranging from the structural analysis and topology optimization we talked about, to composites, to fluid dynamics, aerodynamics, thermal, heating and cooling situations, motion dynamics, manufacturing, additive and subtractive, and especially electrification in this day and age of making things more sustainable, more energy efficient, involving motors, electric drives, batteries, power electronics, even including high-frequency electromagnetics, such as might be involved with antennas on these different parts that are devices that are communicating with each other, and with some base stations as a system of systems simulation. And then also bringing in data analytics for better decisions about the design and operation of these devices. More details about these applications and simulation types are going to be provided in other sessions here. So as an example, some examples of those different disciplines and multidisciplinary type system simulations, you can combine our technologies for 3D geometry-based simulations or 1D block diagrams and 0D equation-based modeling. Really, they can be done separately, they can be done together. By bringing them all together, that enables you to simulate at the system level, which is what we really want. We want to optimize not at the component level or the subsystem level, but at the complete product system of system level, whether it's for multi-body dynamics and controls, wheel to ground interactions and targeting systems, or adding motors in addition to engines that power these systems, adding structural capability so we know when we're precisely picking and placing things that are perhaps flexible, like this sheet of metal, we still need to be able to precisely position it. So we need to add in the structural aspects. Also, just for loading and durability and reliability, especially as we try to lightweight these systems. Adding in other types of actuation besides engines and motors, with hydraulics for heavy equipment, as is shown in this excavator example. And then last but not least, bringing it all together, we add in some aerodynamics, some wind loads on this ground radar system, which is transmitting signals using some electromagnetics technology, in addition to all the others that were shown in these previous examples. Okay, so I'm going to focus specifically in the next couple slides on Altair Inspire. It's one of many tools in the HyperWorks platform. It's specifically useful in academia, we believe, because it's so easy to use, built from the ground up recently with a very modern interface, complements all the different types of CAD software you might be using to build your geometry and your systems, in order to then take that geometry and do structural analysis to avoid breaking, topology optimization to lightweight these parts and systems, motion dynamics to see as the systems move, what kind of loading conditions is that going to put on the parts, and then to manufacture those parts, especially with the ultra affordable and capable 3D printing capabilities now available to us. All in the spirit of what we call simulation-driven design, making sure that the device will work as intended once physically built and operated. Okay, so how can you access Altair software products? Well, bear in mind that for academic users, we're always talking about non-commercial use. If certain faculty or grad students want to do research that's privately funded, that's a different category. This is for students and course instructors that want to use our software for non-commercial purposes. That's what these options pertain to. We have three options here, really. One are free personal editions available to anyone and everyone. I'll describe them more in a moment. We have student editions available free to students who want to install that software on their individual personal computer. And then we have an academic edition bundle of software. The student edition is actually a bundle as well. You get units instead of a license file for an individual product. You get units that run any of our products. The academic edition is available to universities where faculty will contact us to purchase those units and licenses to easily install on many computers throughout a university in a network configuration. So it's very convenient. Install on a server, and then any computer on the network on that university can access our software for a minor fee. Very much discounted off our commercial cost, if at all. We make different deals in different situations depending on the university's needs. So with our personal editions, we have 4 different products: Altair Inspire, Compose, Twin Activate, and Rapid Miner, for which we have these free to the world, free to everyone and anyone personal editions. There are no limitations on those, so those are the best place for you to start if you want to use one of those products. If you want to use one of the other products available from Altair, then I would say install the Student Edition bundle. And if you run into any limitations, because some of those products do have technical limitations, then you can request, student competition teams can request the Academic Edition bundle. So let's look at a few scenarios. This is sort of a flow chart that I hope can help you see how to proceed. As I mentioned, if you want to get this personal edition, then download it. That's the first thing. Easiest, very quick, and frictionless. But if you want to use a product that's not in the, for which we don't have a personal edition, then you have to decide if you're a faculty, obtain the academic edition for use on university-owned computers. If you're a student, obtain the student edition, which is intended for your own personal computer. You can, as a student, you can use our software in both places, in a campus lab of computers or on your own computer, or both. If you hit any limits with the student edition, you can request our free academic edition using the different web links included here. So specifically, a few examples. If you are a faculty or student wanting to try to use Altair Inspire, go ahead, download the free personal edition. It lasts for a year. You can use it to your heart's content as long as it's for non-commercial work. If instead you want to learn how to use a different tool that's not in the personal edition mode, Altair PSIM for power electronics, for instance, with a course, project, or thesis, then that's when you would install the student edition. And then if you hit a limit with a product in the student edition, maybe HyperMesh, where you're building a big finite element model for your competition team, a vehicle or an aircraft, then you can request the free academic edition. Okay, so 3 primary options. Choose the one that's best for you. Use them in multiple ways together if you'd like to. All right, once you have our software installed, activated, in an executable form that you can run, how do you get started? Well, again, there's multiple options available to you. Try to make them as simple as possible. First and foremost, when you open the product for the first time, look in the help menu. There are many times tutorials and examples right there which you can just load in. They're already built, and you can just simulate. That way you don't have to worry about spending hours modeling something and maybe getting it off track, getting something wrong. This will give you immediate gratification and a successful experience. Then I would say also use the links from our Global Academic homepage or website. We're actually in transition mode, so bear with us, please, as we transition to altair.com away from an older site, Altair University, which is going to be discontinued in the near future. But there still are some very nice resources, especially for student competition teams on that older site and throughout the newer site as well. For instance, for SAE formula teams and Baja teams, there's nice examples which you can download and reuse. There are also many, many video tutorials and recorded sessions on our Altair Academic YouTube channel. Using this link, you can reach there and then search for different options for the Inspire video instructional series, the student webinar series from the past, and student competition team stories. We have product-focused e-learning on learn.altair.com, and with the recent acquisition of Rapid Miner about a year ago, they brought a phenomenal learning hub, an academy that has courses, certification, and other material. Last but not least, when you have questions or are looking for expertise shared by others, go into our Altair community, which is the discussion forums and knowledge base using that link. So a final thought in closing. Once you get good at using Altair's topology optimization and lightweighting technology, if that's what you're going to apply in your student competition, consider submitting your work to our Altair Global Student Contest for 2023, which began in May this year and is going to go until April of 2024. It's a year-long competition. We are awarding prizes every month, considerable cash prizes. There's going to be one prize at the end for the very best of the best. So you have a chance of winning $7,500 US. Using this web link below, let us know what you've done. Show us your work. Be proud of your accomplishments. We'd love to see what you can do with Altair technology. With that in mind, I'll conclude and say thanks for joining me. Great luck with Altair technology. We hope you do great things. We're sure you will. Let us know how we can help you be successful and achieve your goals. Take care.